Hello everyone, welcome to the course Formal Languages and Automata Theory. This is lecture number 20. And in the previous lecture, we have discussed about Moore machine to Melay machine conversion. In today's lecture, we are going to discuss about Melay to Moore machine conversion. Let me share the screen to discuss about this. Today's concept is about conversion of Melay machine to Moore machine. And if you have given a Melay machine and how this will be converted to Moore machine. This is a transition diagram already represented for a Melay machine here, and this is a transition table. Now you need to convert this Melay machine to Moore machine, and you know the structure how it will be. You will be having the present state, and in the next state, and you will be having the transitions on 0 and 1 and only the output you will be finding. This is the transition table for a Moore machine. Now based on this, we are going to apply the steps to convert the Melay machine to Moore machine. Right. First we are going to see the present state and next state. In this next state, we are going to observe on Q1 what are the outputs and on Q2 what are the outputs we are going to have. Just you observe on Q1 what is the output on Q1 you are finding. On Q1 you are finding the output N, and on Q1 you are going to find the output Y. In the similar way, if I am going to observe Q2, on Q2 I am finding the output N, and in other case it is finding Y. That means I am getting two different outputs on the same state. In this particular case, how we are going to convert the given Melay machine to Moore machine by representing two different states, two different outputs for the same state. Now we need to take, for Q1, we need to take two different outputs. How it can be represented? Just you observe here. On Q1, if I am going to get the output as N means, then I need to represent its state as Q1N. Q1N, then the output is N. Then Q1Y, then I am going to consider my output as Y. In the similar way, we are going to take it for Q2. For Q2 also, you are finding two different outputs. That's why Q2 on N, what is the last one you are going to find? That is N is representing the output. And Q2Y, it is representing the output Y. Now how we are going to represent the transition table? Based on this, we are going to convert it into transition diagram. This is a transition table which we are going to represent for the Melay machine before converting it to Moore machine. Just you observe, here you have present state, next state, and you have the input symbol 0 and 1. And for that, the states are state output for state and output for 0 and state and output for 1. Now Q0 on 0, it is going to Q1 and the output is N. Now for Q1, we are going to have two different outputs on the same state. For that, what we need to do is, in the first one, we are going to have Q1N. That means the output is N. That's why we are going to consider the state as Q1N. Q1N, then the output is N. In the similar way, on Q2, the output is N. That's why we need to consider this state as Q2N. Q2N and the output is N. And we will be seeing this, why you are getting this as empty one, we are going to see later. First, we will be concentrating on this one. Right, Q1N. Now, what are the new states that are going to be appeared? That is Q1N and Q1Y. For this, we need to write the states. Q1N is nothing but Q1. On Q1, what are the states you are going to get? The same thing you are going to write it for Q1N and Q1Y. Right? Q1N is nothing but Q1. The output is Y here. That's why what we need to do, Q1Y, the output is Y, and Q2N, the output is N. That's why we need to write the state here as Q2N with n. Q to n with n. Now, the same state, whatever you have represented for Q1n, the same thing should be represented for Q1y also. We don't have separate states for it. That's why we need to represent the same state as Q1n. Right? Now, Q2n and Q2y. For this Q2, what are the transitions? Q2, Q1n and Q2y. The output is n, that's why we need to take Q1n, and the output is y, that's why we need to take Q2y. Now, Q2n, here we are going to have Q1n and n, and Q2y as y, and this one we will see later. And Q2y, and that we are going to have Q1n, the output is n, and Q2y, and the output is y. The same thing should be repeated for both the states. Now, after doing this, now we need to combine them. Now we need to combine this, and we need to represent the mode machine. And how we have represent this one, we will see in that after combining the states and output, how we are going to represent this output, right? Now, Q0 on Q1n and Q2n, Q1n, Q1y, Q2n, Q1y, Q1y, and Q2n, Q2n, and Q1n, and Q2y, and Q2y, and Q1n, and Q2y. How we have taken this? We have taken this based on the states which we have represented in the Melay machine. Now, how to represent the outputs? How to represent the outputs? Now, you observe here on Q0. On Q0, are you finding any output over here? We have only the outputs for Q1 and Q2. That is differentiated with n and y. But here for Q0, you don't find any output. That's why we are placing it as NT. Are you getting? For Q0, you don't find any output. That's why we are placing it as NT. Now, for Q1n, why you are going to place the output as n means for Q1n, we have already seen here Q1n, the output is n. That's why we need to place n here. For Q1y, the output is y. We need to place y here. The similar way, Q2n, the output is n. Because of dividing the Q2 into two parts, we are going to get the output, right? Q2y, you are going to get the output as y. Don't consider this one, just you consider based on the states, present states you have represented, and we are going to represent the output. Learning outcomes. By the end of this lecture, the student can able to convert the given Melay machine to mode machine. Thank you.